Hi friends, I'm sorry I can't be there with you today, but we're going to go ahead and get started on the lesson even though I can't be there. So in our navigation, which is kind of our recap of what we learned last time, sorry about that, we now know that clouds are made of water droplets or ice crystals that first form when many millions of water molecules start sticking to cloud condensation nuclei. Do you remember the examples of what a cloud condensation nuclei can be? Let's get some participation. I heard ash, good job. Pollen, oh yeah, pollution. Even tiny bits of salt kicked up by the seawater. The question is though, why don't those droplets or crystals start falling to the ground the moment they start forming? What keeps this stuff that makes up a cloud floating in the air above us? So we said that a cloud is made up of a couple of things. It's made up of gases, and it's made up of water droplets and ice crystals that are suspended in those gases. And at the heart of it are tiny little specks of things like dust, ash, and pollen that started all condensing in the first place. We call those little specks CCN. So why do those droplets stay in the cloud? We know the force of gravity wants to pull them down, but they don't come down right away. They stay up there. So I say we know that the force of gravity would like to be pulling them down, but they stay suspended anyway. Why is that? As we move forward, we're going to be talking about interactions from moving air. We're going to save this one for when I'm there with you, but we're going to see if we can keep a small piece of tissue paper in the air with nothing but our breath through a straw. This idea of pushing up on something with air may be new to us. We maybe never thought of air being a force that can move things around. So we're going to get into some weight investigations. What have we used in the past that will allow us to measure weight? Yeah, a scale. Good job. So we have a scale. We can measure in a couple different units of measurement. Often we've used grams in the past, but today we're going to be talking in ounces because we're talking about the weight of a liquid. So we've got the weight of a piece of tissue. One little piece of tissue on my scale right now weighs 0.025 ounces. This tells us that a piece of tissue is extremely light, less than 1 ounce. Two pieces of tissue, which you might be able to predict if you're a math happy friend, 0.055 ounces. The weight of a ping pong ball, pretty light object, weighs 0.08 ounces. So they're all coming in at less than an ounce. However, if I turn on my air dryer, like I have a hair dryer literally, and I blow it on the scale, that is putting a pressure of 0.420 ounces on the scale. So the force of the hair dryer is actually greater than any of these objects. It's greater than one piece of a tissue and two pieces of tissue, and even greater than a ping pong ball. I'll be showing you in person tomorrow, but we can use the force of the hair dryer to keep those things aloft. So what I recorded was the force of the air pressure has weight. It is pushing upward with a force that is greater than these things are being pulled to the ground. One piece of tissue, two pieces of tissue, a ping pong ball are all very light objects. And in this case, the blow dryer is able to keep them pushed up. We are going to use this information to look at some specific objects. So I've never considered the weight of any of these things before, okay? One little small snowflake, let's think about that. One little small snowflake weighs 0.0001 ounces. One little water droplet, so I'm going to draw a single water droplet. I think perhaps we can use our strategy. We're going to draw something nicely one time, and then we'll be able to copy paste it a couple times. Okay, so I've got a small snowflake, a small water droplet. Let me give it a little, look at this, we're going to give it a little shading. Look at that, beautiful. We will also have a large water droplet. Make that guy a little bigger. A small hailstone. So remember, your hailstones have layers when they freeze in the clouds. We can use our copy paste tool to say we are needing a larger one as well. Okay. So what do we have? We have a small snowflake, a small water droplet, a large water droplet, a small hailstone, and a large hailstone. Now we just have to do some mathematical comparisons, okay? So if we think about the little water droplet, the snowflake, we can see that the snowflake has a weight of 0.0001 ounces. And the updraft, the air pushing up on that snowflake, has a force of 0.01 ounces. When we look at this, we can compare these two. 0, 0, it's a tie. 0, 0, it's a tie. 0, 1, we have a winner. So in this case, we would observe that it rises. So I'm going to do a little bit of squish squashing. Hold on, I'll make sure I leave more room next time. So this little small water droplet, when faced with an updraft that has 0.01 ounces of force, is going to rise. I'm going to try to draw everything nicely one time, and then I'll be able to copy, paste, copy, paste, copy, paste. So, rise. Okay. Let's go again. We've got our small water droplet that has a weight of 0.001 ounce. And it's going to fight a weak updraft that has a force of 0.01 ounce. 0, 0, it's a tie. 0, 0, it's a tie. 0, 1, we have a winner. The updraft is stronger than the force pulling down on that little water droplet. So up it goes. Large water droplet. Okay. See, again, we're just using that copy, paste all the time so we can talk about things clearly, so we can have picture representations, but we're not like working so hard to get the job done. So we've got a large water droplet. It's telling us that the weight of that water droplet is 0.01 ounce, okay? 0.01 ounce. And the strength of the updraft pushing up on that water droplet is 0.01 ounce. Well, this is interesting. 0, 0, it's a tie. 0, 0, it's a tie. 1, 1, it's a tie. The water droplet isn't going to rise. Because it's perfectly tied, it just stays suspended. There's a word for that. It says suspended. Just stays in the same spot. Let's think about that hailstone. That hailstone's a little heavier. The hailstone has a weight of 0.1 ounce. And the weak updraft has a force of 0.01 ounce. Let's compare. 0, 0, it's a tie. 1, 0. Oh, the hailstone is heavier than the force of the updraft pushing up on it, which means that hailstone is going to fall out of the cloud. It's coming down. So if a small hailstone falls, I'm going to go ahead and guess that that large hailstone definitely falls. Let's see. The large hailstone has a weight of 1.0 ounce. Oh yeah. And the weak updraft only has a force of 0.01 ounce. The large hailstone wins right away. 1 ounce compared to 1/100th of an ounce. That hailstone is going to fall. Pulled back down to the earth by the force of gravity. So we would see that a little snowflake is going to rise. A little raindrop is going to rise. A large raindrop would stay suspended in the atmosphere. A small hailstone is coming down. And a large hailstone is definitely coming down. What if we increase the updraft? This wind is quite a bit stronger than before. 0.1 ounce of force. So I think we can take some of this information from before. We've got the information on our small snowflake. Copy, paste. We know the weight of the small snowflake is 0.0001 ounce. The large updraft, on the other hand, has a force of 0.1 ounce. Let's compare. 0, 0, it's a tie. 0, 1, the large updraft is winning. The large updraft is able to push the small snowflake up and higher into the atmosphere. Our small water droplet when compared to the force of our strong updraft, 0.1 ounce of force. 0, 0, it's a tie. 0, 1, aha, the updraft wins again. So far, I'm going to go ahead and think there's a lot of rising, but let's see. The large water droplet compared to the strong updraft, 0.1 ounce of force. That's rising as well. Sorry, this is getting a little squish-squash. We'll do our best, okay? Now, what's going to happen with the small hailstone? So we got the small hailstone. I might just copy paste two at once. Copy, paste. There's my large hailstone as well. Copy, paste. The force of my strong updraft is 0.1 ounce of force. 1 ounce of force. So let's compare these numbers. 0, 0, it's a tie. 1, 1, it's a tie. Okay, this happened once before. This means that the small hailstone isn't going to rise. It isn't going to sink. It's going to stay the same. It's going to be suspended. It's going to be sort of equal. Oof. 1, 0. Ooh, we already have a winner. The hailstone is coming down with a force greater than the updraft is pulling up, which means it's going to fall. It's going to be sinking in the atmosphere, returning to the earth. It is being pulled down with a force greater than it's being pushed up. So this table is very much about these battling forces. We got the force of gravity pulling things down, 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 and the force of the updrafts pushing them up, with hot air rising. That less dense hot air rises up, up, up. So independently, we're going to practice with a couple of these things. We've got some really excellent notes, and we are going to see lots of examples so we can make a choice. Is the water droplet, is the snowflake going to be suspended? Is it going to rise in the atmosphere? Or is it going to fall back down to the earth? So we'll practice independently in just a moment. In addition, we want to be thinking about what would cause the strength of updrafts in the air to change on one day versus another, or under one cloud versus another. I think that updrafts could be stronger when that would mean that updrafts would be weaker when I'm going to have you answer these in our independent practice, which is coming up shortly. If you want to jot down your notes, you definitely can. Then we're also going to watch a little bit of a video on how a barometer works. And we're going to be answering a couple of questions based on this weather map in our independent practice. So for today, right now, your goal is to make sure that you have this page of notes and you have this page of notes. And if we had to prioritize one as being the most important, it is this one. Thank you for working hard on your notes. Please do the best you can on your independent practice. Thank you.